For this example, we'll graph a conic section. We have 4x squared minus y squared plus 8x plus 2y plus 7 equals 0. So it's in general form. We first have to put it in standard form. And let's notice that we have the x squared and the y squared term on the same side of the equation. One has a positive coefficient, the other has a negative coefficient, so this indicates that it's a hyperbola. So we're going to put it in standard form by completing the square. So let's collect the x squared and the x term together and factor out a 4 at the same time. So we have 4 times the quantity x squared plus 2x, and we're going to complete the square, so we'll leave some space. And then we have a y squared and a y term. Let's collect these terms at the same time, factor out the negative 1 from the y squared so that the y squared term also has a positive 1 coefficient. So we'll have negative 1 times the quantity y squared, and then we're going to have minus 2y, because if we distribute this negative 1 back through, we would have negative y squared plus 2y. And we'll leave some space, and we'll put the 7 on the right-hand side, and it becomes negative 7. So let's complete the square. Half of our linear coefficient 2 on x is 1. 1 squared is 1. So we add 1. Now, we really had the effect of adding 4 times 1, or 4, because this 4 is in front of the parentheses. So on the left-hand side, we really just added 4, so we'll do the same on the right. Let's complete the square on y. Half of negative 2 is negative 1. When we square that, we get 1. Now we really just subtracted 1 because we have this negative 1 in front of the parentheses. Negative 1 times 1 is negative 1. Because we subtracted 1 from the left, we'll also subtract 1 from the right. Now we'll rewrite it, and we have 4 times the quantity x plus 1 squared minus 1 times the quantity y minus 1 squared, and that's equal to, on the right-hand side, we have negative 4. Now remember, with a hyperbola, in order to put it in standard form, this term on the right-hand side has to be a positive 1. So we have to divide each term on both sides by negative 4. When we do that, we have 4 divided by negative 4 gives us negative 1, so we have x plus 1 quantity squared divided by negative 1. The minus minus becomes plus. We have y minus 1 quantity squared over 4 is equal to 1. Now this is a hyperbola. Normally in standard form, we put the square term with the positive coefficient first. Since the y squared term has a positive coefficient, we'll rewrite it so that that term comes first. So we have y minus 1 quantity squared over 4 minus x plus 1 quantity squared over 1 is equal to 1. I just changed the order here. Now we have our hyperbola in standard form. Now we're ready to get the information in order to graph it. So here's the equation one more time. I've written it at the top, the equation of our hyperbola in standard form. Standard form is really y minus k quantity squared over a squared. In a hyperbola, the a squared term always comes over the squared term with the positive coefficient. So it's going to be y squared over a squared minus x minus h quantity squared over b squared is equal to 1. So we can pick out some information now. We're ready to state the center. The center is always going to be h comma k. So be careful, we want to go to our x term first. It's x minus h, so our x coordinate of our center is really negative 1. The y coordinate of the center will be positive 1. Our a squared is equal to 4. So therefore, a is equal to 2. Let's start by graphing this information. We can see that our center will be located at -1, 1, and A is equal to 2. Because our transverse axis is the y-axis, or parallel to the y-axis in this case, because the y-squared term is positive and it comes first, that means that our branches will be opening up and down. So from our center of -1, 1, we're going to go A units up, or 2 units up, right here. That will be our first vertex. The vertex will be located at -1, 3. From that center, we'll also go 2 units down to -1, -1. These are our 2 vertices. Now we also need information about b squared. B squared is equal to 1, so therefore b is equal to 1. So from our center, we'll go b units to the right and b units to the left so that we can form our rectangular box. Let's do that now. The rectangular box will help us draw in our asymptotes on the graph. So we draw the diagonals through the corners of this rectangular box. These are our asymptotes that help us sketch our hyperbola. Now, we know that the branches will be opening up and down at each vertex, so I'm going to go ahead and sketch those in. I'll draw the hyperbola in red. From this vertex, the branches go toward the asymptote, and from the other vertex, the branches also go toward the asymptote. Now we have a sketch of our hyperbola, but we're asked for a little bit more information. We also want to find the location of each focus. In a hyperbola, we can find information about the focus using the equation c squared is equal to a squared plus b squared. So in our case, we have c squared is equal to a squared, which was 4, plus b squared, which was 1. So therefore, c squared is equal to 5, or c is equal to the square root of 5. So the focus always lies along the same axis as the transverse axis. So we could say that we have one focus located the square root of 5 units above the center, the other focus located the square root of 5 units below the center. So the location of those points would be, I would have -1 for the y-coordinate, and then I would go up 1 to my center, and I would add the square root of 5 for my first focus. The other one would be at -1, 1 minus the square root of 5. And those would be located right about here and here. We have one more thing to do when dealing with hyperbolas. We want to come up with the equation of the asymptotes. For a hyperbola with the y-squared term first, the equation of the asymptotes are of the form y is equal to plus or minus a over b times x, and we simply need to shift according to the center. So instead of y, we'll make sure we use y minus 1, and instead of x, we'll make sure we use x plus 1. So we have the equations y minus 1 is equal to plus or minus, well, a is 2 and b is 1. So 2 over 1 is just 2 times the quantity x plus 1. Those are the two equations of our asymptotes, and here's a complete graph of this hyperbola.